Hi everyone, welcome to my YouTube channel. Today my topic for this particular video is the multi-threading and multiprocessing. So let me start with multi-threading, then I will move to the multiprocessing. So multi-threading basically a technique in the Python to run a program or run a task in the concurrent mode. It basically achieves the multitasking on the same time by run a program in the concurrent mode. Those we call the multi-threadings. So let me first explain the difference between the concurrency and the parallelism. So concurrent execution means that two or more tasks are processing at same time. Like we run two or three or more than two tasks on the same time in the concurrent mode. And parallel means we execute two or more than two or more than two jobs or tasks in the in parallel. So suppose this is the one task and this is the second task in the parallel mode. So in the parallelly, those called the parallelism, parallel execution. And concurrent means this is the one task is run, then the second task is run. Like the one task is waiting for the input from the users or waiting for some data. Then the meantime we run the second task, and both the task is utilizing same memories or the same computation. So those the example of concurrent. Parallel means we run the parallelly to program on the different resources like different CPU core or different memory. Those parallelly run. Those are the example of parallel execution. And concurrent means this is the task one, this is the task two. Suppose task one is waiting for the input, task two is run. And so these are the difference between the concurrent or the parallel execution. And basically multi-threading is example of the concurrent mode, and multiprocessing implement the parallel execution. So there is the two things. Concurrent, if we have the requirement to implement the concurrency, then we go with the multi-threading. If we have the requirement to implement the parallelism, then we go with the multiprocessing. So first, let me start with the multi-threading. I will discuss the threading first. So in computer, we know like the processes run on the computers, like each process is run on the separate CPU core under the systems, under the operating system. This is on the operating system level. So let me show you here. This is my my computer. And if you see, this is the my laptop, and you can see here, these are the different processes. These are the different number of processes running here. And these processes is utilizing the CPU. You can see here CPU, memory, these. So these are the utilizing by each processor. And each process has the separate. You can see here, each process has the separate memory assigned dedicated to each process. So these are the example of processes. So you can see here, same thing. These are the processes currently on this system. 266 processes is running on this time. And in case of threads, there is 3,562 process threads is running. So we have the 200 plus processes and 3,000 plus threads. So that's the example of process and threads. Under one process, we have the multiple threads. Like we have the 200 plus processes and 3,000 plus threads. So under each process, we have the multiple threads. This is the basic of the threads or the process on the operating system level, how the things work on the operating system levels. So same thing mentioned here, like in a computer, each thread is executed inside a CPU processor core. Like each process is run on the CPU core, and each process has the dedicated memory, dedicated hardwares, like the dedicated CPU, dedicated memory. Each process has the dedicated separate CPUs, core, and separate memory. In case of processing, process is not sharing the data, not sharing the computation, not sharing the memory, but in threads are the part of process. So we have the process. Under the processes, we have the threads. So you can see here, computer, a process is executed inside a CPU core. So you can see here, process is executed inside a core, as I show here in the systems also, in this laptop also, how the process is utilizing the CPU. and each process has the dedicated memory and CPU core. Further, threads are the part of process. Threads basically child of processes. Threads is run inside the processes, and we can run multiple threads inside a single process. You can see here, same thing mentioned. We can run multiple threads inside a single process, and those called the multi-threadings. If we run the multiple threads in a single processing, those technique we call the multi-threading. And these thread, basically these multiple threads share the all resources of a process, like the memory, which assigned to a particular process, which is shared by the all thread, which run inside those process. Basically, multiple threads share the data and share the memories inside the particular process. And you can see here also same thing mentioned. So in case of shared data requirement, multi-threading is preferred approach. However, process are not share the memory space. So same thing as I show here, like each process has that dedicated memory assigned to each process. These processes are not sharing the memory. You can see here. So multi-threading is sharing the memory, but processes is not share the memory. So let me explain with the help of this diagram. So this is the first example is for the single thread. This is the single thread example. And in the single thread, we have the multiple tasks. This is the task 1, task 2, task 3, task 4. These are the multiple tasks. And we run in the with the help of single thread. Like the first task 1 is completed. Then while completion of the first task 2, task 3 are in the waiting mode because we are running in the single thread in the sequence mode. So this way, like this thread is run, and this thread has separate register set, stacks, thread ID, like unique thread ID, and this data is shared by all the threads. But here are the single threads, so this data is accessed by this thread. Codes, program files, memory, all things is accessed by this single thread because here are the single thread. This is the example of multi-threading. So here basically we divide these tasks, these are the 4 tasks, into the multiple threads. This is the thread 1, thread 2, and thread 3. And we assign 1 task to thread 1, and here are the 2 tasks to thread 2, and 1 task to thread 3. So this way we run these tasks in the concurrent mode. Suppose these task is waiting for the input from the users or from the other program, then this task is running. This task is run in the system. This task basically utilize the CPU or memories in the concurrent mode. And suppose this task is wait for the input from the other program, then this task is run. And this task is utilize the CPU, utilize the memory. So this way we run the program in the concurrent mode. This is the example of multi-threading. And each thread has separate thread ID, thread identifier. You can see here thread ID 1, thread ID 2, thread ID 3. And also each thread has separate register set, stacks, separate registers for the thread 2, for the 3 also. And these register set is responsible to assign the memory, assign the cores for each thread. And further the data, cores, files, all things are shared by these all threads. Like all threads is access the same data source. So in case of shared data, we prefer the concurrent execution. So this way, like we share the data, code, and file among these all threads. So this is the example of multi-threading. So let me back here, like on the operating system level, we know like on the operating system level, first we have the CPU, memories like the RAM and hard disks, and then we have the processes. Processes run on the CPU cores, and processes utilizing the RAM and CPUs as per the requirement, as per the assignment. And then we have the threads under the process. And threads are basically managed by or protected by thread control blocks, TCB. So you can see here, TCB, thread control blocks, is manage all threads. All the information is maintained by this TCB. like the thread ID, priority, pointer, all the things. So here are the few metadata regarding the threads. So let me explain these things. First is the thread identifier. Thread identifier basically the ID. Once a thread is generated on the system by TCB, then unique ID generated by the operating system. Those unique identifier is called the thread identifier. Then we have the stack pointer. Stack pointer basically point the process which thread need to create, which thread need to execute. This is to point the process. Then we have the program counter. You can see here program counter, and program counter basically store all the step is executed by a particular thread. It maintain the step records. And then on the fourth, we have the thread state. So thread states, there are the multiple thread states like the running, ready, wait, start, or completed. In case of completed, we have the done status. So these are the separate status of the thread. And then we have the thread priority. So it helps the thread scheduler, or it helps the TCB to run the next thread, to schedule the next thread as per the priority. And then in the end, we have the register set. And each thread has its own register set, which assign the computations to each thread. So that's all about the multi-threading. Let me show you the code example. So here are the code example. Here I'm first importing the threading module here, threading, import threading. This is the threading module. And also I'm importing the OS module. And first I create 3 function here. Function, you can see here, these are the simple programming. As I discussed in the function part also, like I create a function with the help of def keyword, and then this is the function name, and this is the print statement. So this is the simple string. You can see here first thread is start and the current thread name. So here is the thread name. So here I'm inserting thread name by using the thread dot concurrent thread. So here by using this function from the thread module, this basically return the thread ID. So here I'm inserting the thread ID. And from the OS level, like we know the process is run on the OS level. So from the OS dot get PID, I'm getting the process ID here, and then I'm inserting the process ID here. You can see here. This way I'm inserting the thread ID and the process ID. This is the first function, first thread task. This is the second function. This is the third function. Next, I move to the multi-threading, how we run these function into the concurrent modes by using the multi-threading. So first we need to create an object by using the thread class, and we need to pass 2 arguments. One is target, 2 keyword argument. One is target, second one is the arguments. Target value is the function which we need to execute in the parallel mode, execute by this particular thread. And second is the argument. We can pass any number of argument which we need to pass to this function. So here you can see I'm not passing any argument here. You can see here bracket are blank. So that's why I'm passing just target here. So you can see here I'm basically creating an object. So this is the module which I import about threading dot thread. So here I'm calling the thread class, and in the thread class I'm passing this argument, keyword argument target, and this is the function name, first thread task. And here I'm creating an object thread underscore 1 for the first thread. Similarly, I creating the second object for the thread 2, and third object for the thread 3 is the thread underscore 3, and I'm passing the separate function to each thread. You can see here are the second thread task. This is the second function, then the third function. And then I need to start this thread. So here are the codes to start this thread. This is the object of thread 1, and then we have the function start. This is the way we can start the thread. This is the way we start the first thread. And then similarly, we start the second thread and then the third thread. And then we need to wait for the completions, like the execution of all threads. So this is the functions, join function, which basically wait for the completion of execution for thread 1, thread 2, and thread 3 similarly. And after the execution of this program, you can see here, this statement is written, and this is the thread ID, like the thread ID for the first thread is thread 11, for the second thread is 12, for the third thread is 13. You can see here, all three thread has separate thread IDs, but you can see here, process ID is 60 in every case. For the thread 11, process ID is 60. For the thread 12, process ID is 60. For the thread 13, process ID is 60. So this way, like we can run multiple thread on a single process. And let me move to another example. So here in this example, again, I'm importing the threading module here, and here I'm running single function. So in the previous example, I run the three separate function on separate threads, but here I'm running the single function on the three separate threads. And here basically I'm performing a computation. First, I'm dividing the data into the three section, and then I perform the summation of those three section. So here, first I'm defining a function. So first I'm creating a list here to store the data from each thread. And then I'm defining a function. Function name is multithread function. And these are the argument I'm passing: argument 1, argument 2, and the thread number. And then I'm using the for loop uh, to add these numbers. So here you can see here, these I start from argument 1 up to the argument 2 here. So basically I'm adding these all numbers and then storing this data into the list. You can see here this way. And here basically I'm defining the range here 3 lakh, and then dividing these 3 lakh by 3 because I'm interested to run the 3 threads here. So I basically divide the 3 lakh data set into the 3 parts. First is 1 to 1 lakh. Second range is 1 lakh 1 to 2 lakhs. Third range is 2 lakh 1 to 3 lakh. You can see here, this is the logic to divide these data into the 3 section. And then I'm passing this data into the each thread one by one. Thread 1, in the thread 1, I'm passing data from 1 to 1 lakh. T1 value is 1 lakh. And in the second thread, I'm passing the data from 1 lakh 1 to 2 lakh. And in the third thread, I'm passing the 2 lakh 1 to 3 lakh. In the end, I will print this. I will show you in the end. And this way, I'm creating the 3 threads. In every thread, I am calling the same function. You can see a same function, and I just change the argument for each thread. This is the same syntax to above. You can see here. Similarly, similar to this, again creating the 3 threads here. And now again, I'm starting this thread here. You can see here, this is the syntax to start the thread, and again wait for the threads. And here in the end, I'm printing the result. And you can see here, these are the section. We divide the data into 3 range. First on the 1 to 1 lakh, then 2 lakh, 3 lakh, and these are the summation of these each range. This is the end result which we store into the list. So these are the 2 examples how we can pass the same function, how we run the same function into the concurrent modes by using different arguments. And here I show you how we run the separate function in the concurrent mode, like how we run the each function in the concurrent mode. So now I move to the multiprocessing. So here are the multiprocessing. So multiprocessing is the actual example of the parallel execution. Multiprocessing basically means is the capability of the system to run the multiple processes in parallelly on the different core of the systems. And it preferred when we have the computation bound tasks or we have the CPU bound tasks. So it basically parallelize those computations, and it's assigned those computations to different cores, and it's reduce the execution times and the computation time. And you can see a same thing mentioned here. Multiprocessing basically divide workload among the multi-core CPU to speed up the computation. And let me show you the diagram here. So this is the example of multiprocessing. Suppose this is the process 1, this is the process 2, and each process has separate core. You can see here core 1, core 2. Each process has separate core. Each process has separate memory. You can see here cache, separate memory, and each process has separate register, which is responsible to assign the computation resource to each process. So you can see here, each process has separate data, separate memory, and separate CPU core. So this is the example of multiprocessing. And this is the actual parallel execution. All the things are separate. In the multithreading, so we have the shared data, we have the shared memory, because we run the multiple threaded under the single process. But in case of multiprocessing, we have the separate CPU core, we have the separate memory, all things are separate. This is the real example of parallel computation. Let me show you the code. So here I'm importing the multiprocessing module here. And from the multiprocessing module, I'm importing the process and queue, two classes here. Process basically to run the process in the parallel mode, and queue basically to store the data from the each process. And then I import the OS again. And this is the same function which I run above. You can see here, this is the same function. This is the same function. And again, I'm passing the same amount of data up to the 3 lakh. And then again, I'm dividing this data into the 3 sections. And here I'm defining the queue to store the data. Queue basically the stack to store data into the first in, first out format. And for the details regarding the queue is out of scope for this video. In case of any queries, you can comment on this video. If you want the detail regarding the queue, I will create the separate video if required for the queue. But here my focus only on the multiprocessing or the parallel execution or the multi-threading. So that's why I'm skipping the queue here. So here basically I use queue to store the data from the multiprocess. So again, in case of multiprocess also, we need to call the process class and we need to create the object similar to multi-threading. You can see here I'm calling the multiprocessing module, then process class, then pass two argument, target and argument. You can see here I'm passing two keyword argument, target and the argument, which is very similar to in the previous multi-threading section. We pass the two things, target and argument. In the target section, I pass the function name. In the argument, I'm passing the argument value. This one also similar to previous example. And now I created the 3 object for these processes, process_1, process_2, process_3. And in the three process case, I pass different argument. You can see here. And then again, I'm starting those process. And you can see here, this is the same syntax to the multi-threading. We need to start with the start function, process and dot start. Then the second process, third process. So this way we are start the process. And then we have the join to wait for the process completion. So this is the similar syntax to the multi-threading. Here also the same syntax. And then I'm printing the data range here. So this is also similar to previous one. And here are the things. Here I'm printing the process IDs. You can see here, first process ID is the 516, second process ID 519, and third process ID is 522. So you can see here, each process has the separate IDs. So this is the example of multiprocessing. In the previous example, if you remember, let me back to the multi-threading. Yeah, here you see we have the multiple threads, like the thread ID is different, but the process ID is same, because we are running these multiple thread on the single process in this multi-threading example. But here the process ID is changed. You can see here I'm running the 3 different processes in the parallel mode. First process ID is 516, second one is 519, third one is 522. So this way we run the multiple processes. And in the end, I'm using the while loop to print the value from the queue. So this is the queue. Dot get is the method to get the value from the queue. And here are the values. And if you compare these value, also similar to our previous execution in multi-threading, this is the same value. Now I move to the use case, like the real-time use case, where we require the multi-threadings and where we require the multiprocessing, because now we have the 2 things. Well, one is the multi-threading, one is the multiprocessing. So how we know, like in which situation we use the multi-threading or the multiprocessing. So multi-threading basically use if we have the input output intensive task. Suppose our application is taking input from the end users. Same thing mentioned here. In case of multi-threading, you can see here. Suppose your application is taking input from end user through the UI or through the web scraping or through the streaming also. Then most of the time our program is need to wait for the input, wait from the input from the user, from the web scraping script or from the stream. So in this situation, multi-threading is preferred as compared to the multiprocessing. Same thing mentioned here, like the multi-threading is preferred as compared to multiprocessing, as thread will start once program got the input. So thread basically wait for the input and it start once it get the input from the user end or from the scraping end or from the streaming end. And only one thread in this situation, only one thread is wait. We know in case of multiple thread, all the thread is using the shared data, using the same memory and computation under one process. So one thread is on the wait, so other thread is continue execute, and they are utilizing the computation, they are utilizing the memory, they are utilizing the CPU core, because one thread on the wait. But if we use the multiprocessing in this case, it's like we use the multiple processing to take the input from the users, then process multiple, like the one process is on the wait. So one process on the wait means the memory of those process on the wait on hold, CPU core is on hold. So that's the way we waste the resources. If we use multiprocessing in these input output bound task or in, so this is the reason why we require the multi-threading in case of input and output intensive tasks, because in this situation, like the multiprocessing is waste of the computation resources. And further move to the computation bound tasks like the CPU intensive tasks. Suppose we have the large amount of data and we need to perform the transformation on the data, on the mathematical operation on the data. Specific to the data science, in the data science, most of the time we have the large amount of data, like the big data. We need to perform the transformations, cleanings, feature engineering. During the feature engineering, we perform the different transformation on the data. So to speed up those transformation tasks, to speed up those CPU tasks, we need to divide those tasks and assign those tasks to different cores of the CPU. So basically, we are parallelize those tasks. So this way we use the multiprocessing, and in this situation, multiprocessing is preferred. So same thing mentioned here. Suppose you need to work on large amount of data, like transformation of data, mathematical operation of data, then you can apply your data on multiple core of CPU, and it reduces the computation time. GPU is the nice example of the parallel processing. In the GPU, we have the multiple graphical unit. We divide our data and the task to multiple graphical unit, and each graphical unit has separate memory, separate resources. Each graphical unit basically perform the computation in the parallel mode, and they reduce the computation time in this way. So GPU is the nice example of the parallel processing. So this is the use cases where we use the multi-threadings or where we prefer the multiprocessing. So in case of input output intensive task, then we go with the multi-threading. In case of CPU intensive task or the computation intensive task, then we go with the multiprocessing. Now I move to the challenges of the multi-threading programming. So first one is the loads. So in case of simple multiple threadings, we can easily design the flow of the program like that. This is the thread 1, thread 2, thread 3. These run in the concurrent modes. But in case of complex programs like the real times in the industry, it is hard to design these flows because there is the challenge of like the common data is shared among the multiple threads. So same things mentioned here is like, suppose we have the requirement to share the common data by multiple threads, then it make the challenge like the thread safety and the race condition challenge on the real time. Then we use the lock mechanism to fix these issues like the race conditions or safety thread safety issues. So let me explain with the help of one data set. So here basically I'm creating a list. The name of the list is common list, and these are the values 10, 20, 30, 40, 60 up to the 80. These are the value of this list. Now suppose we have the requirement to create two tasks and to run those tasks into the multi-threading modes. So thread 1, we need to run a task which basically iterate on all item of this list and then multiply each item by 2. So first task is to multiply each item by 2, and those tasks we need to run on thread 1. Further, we have the thread 2, and then we have the second task is to delete item which is greater than 40. So this we need to run on thread 2. So here are the two tasks and two thread. We need to run each task on each thread, and you can see here the output of each task is depend upon the flow of these thread execution. If thread 1 is executed first, then the output will be separate in thread task 1 result, and then thread second is executed after modification of thread 1, then the output is changed. In case of first execution, like thread 1 is execute first, thread 2 execute second, then the separate output. If thread 2 is execute first and thread 1 is execute after the 2, then the output would be this different. So this is the challenge of race condition or thread safety. And let me show you the with the help of this example. So you can see here, like the result would be depend on execution of flow of thread. If thread 1 start first, then the result for first task would be 40, because we are in the thread 1, we have the task to multiply each item by 2. So here are the items, and now we are multiplying these item by 2. You can see here output for this task is 20, 40, 60, 80, 100, 120, 140, 160. So these are the output for the first task. And then the second thread is run. So this is the output for the second task. Like we are deleting all the element which are greater than 40. So 20 and 40, these are the output of second task. And suppose if we run the thread 2 first, like the thread 2 first, and in the thread 2 we have the task to delete the item which is greater than 40. Then it delete all the item which are greater than 40. So these are the original list, and it's deleting all the element 50, 60, 80, because these are the greater than 40. So output for the second task is 10, 20, 30. So you can see here, now output is changed for this task. As flow is changed, output also change. And for the first task also, output would be changed. Now we are multiplying these output of the second thread by 2. You can see here 20, 40, 60, 80. Now output, this is also changed. This is the output once we execute thread 1 first, and this is the output if we execute thread 2 first. This is the output for the first task. So this way you can see here the output of the program is depend upon the execution of flow of threads in concurrent mode. So here basically we use the loop systems. We basically loop the object. If a object is used by one thread, then we loop those objects, and then other thread is need to wait for unlocking of object. But to design these loop systems, we need to take care like the few challenges. There is a situation like if all the object is locked on the runtime, then there is the deadlock scenarios. We need to take care the deadlock scenarios while designing these loop mechanism. Let me show you the deadlock here. So this is the example of deadlock. So this is the thread 1, and this thread 1 basically accessing the object A. This is the object A, and this thread 1 is accessing this object A, and this object A is locked by our thread 1 because we are implementing the lock mechanism here, and this object is locked. No other thread can access this object. Now we have the another thread, suppose thread 2, and this thread is access the object B, and this object B is locked by thread 2. So you can see here, this is the thread 1, and this lock the object A, and this is the thread 2, this lock the object B. Now next task for thread 2 is to access the object A. So suppose this is the flow, like thread 2 first access the object B, then access the object A. Now this thread 2 is wait for the unlocking of object A, which is locked by thread A. And thread A task, next task is to access the object B. You can see here B object, which is already locked by thread 2. So now thread 1 is waiting for unlocking of B, and thread 2 is waiting for unlocking of A. You can see here both the thread on the waiting mode. First thread is waiting for the unlocking of B. Second thread is waiting for the unlocking of A. So you can see here both the threads is on the waiting end. So this is the situation of deadlock. This is the object is locked by thread 1. This is the object. This is locked by thread 2. And both the threads are on the waiting. So this is the situation of deadlock. So while designing the lock mechanism, we need to take care of these things. While designing the real-time multiprocessing and all things, we need to take care of these things on the designing phase. Further, we have the global interpreter lock system, which is take care of this deadlock situation. Basically, in the C Python, we have the GIL. GIL basically the global interpreter lock system. This allow to run one thread at a time on the interpreter end, on the back end, on the Python, on the execution end. So GIL basically responsible to run one thread at a given time to avoid the deadlock situation. But this make impossible to take the advantage of actual multi-threadings on the real time on C Python. Further, we have the few other libraries in case of distributed programming requirement, parallel programming requirement. We can prefer to joblibs, Spark, sklearn. In sklearn also we have the parameters to run the our model on the multiple cores, like suppose in case of random forest from the sklearn libraries. In case of joblib also we have the capability to run the different cores like the for loops and for on the multiprocessing or in the parallel modes, and also we can cache the data. And further, we have the Spark to handle the big data size. Spark also providing us the capability to run the program into the distributed mode. So that's all about the multi-threading and multiprocessing. So in this particular video, I cover the multi-threading, multiprocessing, concurrent programming, like the concurrent execution of tasks, parallel execution of tasks, and the limitation of the multi-threadings and the use case of multi-threadings, multiprocessing. And in the end, I discussed the lock mechanism, deadlock situation, and the GIL also. So that's all about the multi-threading and multiprocessing. Please like and subscribe my channels. And if you require this course, you can access this colab from the description of the videos. I will put the colab link in the description of the videos. And if you require the more information regarding the multi-threading and multiprocessing, you can comment on these videos, then I will get back to you in this. Thank you for watching this video.